Previously, in 8051 microcontroller video series, we have gone through block diagram, pin description, and the RAM structure of 8051 microcontroller. Today, we are going to see with program status word, a special function register of 8051 microcontroller. This video series is presented by RLC-EEE. Without wasting our time, let's begin the topic. Program status word. Program status word is an 8-bit register, and this register is also known as flag register. Program status word is an 8-bit register which is also known as a flag register. We call this as a flag register because it has 4 arithmetic flags. It has 4 arithmetic flags. Those 4 arithmetic flags are carry flag, auxiliary carry flag, then overflow and parity flag. These are the 4 arithmetic flags which are present in the program status word. So we call this PSW or program status word register as flag register. Along with this, it also has 2 register select bits. It also has 2 register select bits which are of RS1 and RS0, and we have 2 user flags. Those 2 user flags are F0 and bit number 1. This is a brief introduction about the program status word. We'll see with each and every bit now. Friends, don't forget to watch until the end of the video to know the bit address of each and every flag and the register select bits. We'll start our explanation from the carry flag. Program status word, it's an 8-bit register which we have seen now. This carry flag is the 7th bit. Okay. If we count from, this is 0, that is the LSB, and this will be the MSB. So carry flag is at the MSB position. So 0, 1, 2, 3, 4, 5, 6, 7. That is PSW.7th bit is the carry flag. This carry flag will get affected by arithmetic and logic functions. The carry flag will be equal to 1 if there is a carry out from the D7 bit. If there is a carry out from the D7 bit, and it also gets affected when we are going to perform subtraction operation. If there is a borrow, into the D7 bit, then also the carry flag will be set to 1. The carry flag will be set to 1 in 2 conditions: when there is an carry out from D7 bit, or if there is a borrow into the D7 bit, or else this carry flag will be set to 0. We'll see with an example to understand it easily for addition and subtraction operation. We'll consider 2 numbers. These 2 numbers, I say it as this one, it is an 82H, then this is A2H, that is, this is 8 and this is 2, this is A, this is 2. So we'll perform the addition operation and we'll see how it is going to be. So 0 plus 0, if we are going to consider, it is 0. Then 1 plus 1, 0 with a carry of 1. Then 1 plus 0 plus 0, it is 1. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 0 is 0. Then 1 plus 1 is 0 with a carry of 1. 0 with a carry of 1. Now we can see we got the carry generated from the D7 bit. This is the D7 bit. This is D0. So it increases from right to left. That is LSB to MSB. If there is a carry out from the D7 bit, then the carry flag will be set to 1. Then the carry flag will be set to 1. We'll see one more example. Okay, then we can easily understand. Now, in this one, this number is 22. This number is A2, same. Now, when we add these two numbers, 0 plus 0, 0, 1 plus 1, 0 with a carry of 1, then 1 plus 0 plus 0 is 1, then 0, then 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 1 is 1. Now we can see when we add the D7th bit, okay, there is no carry. It has been 0. This means the carry flag is set to 0. This means the carry flag is set to 0. Whenever there is a carry generated from the D7th bit, then the carry flag will be set to 1. Whenever there is no carry generated from the D7th bit, then the carry flag will be set to 0. This is with addition operation. This is with addition operation. It is not only for the addition operation the carry flag is being affected. It also affects for subtraction. We'll see with an example for subtraction now. Now we'll consider the same two number. Here it's been interchanged. This is A2, this is 82. Now we'll do the subtraction operation now. So 0 minus 0, it is 0. 1 minus 1, 0, then 0, 0, 0. 1 minus 0 is 1, 0 minus 0 is 0, 1 minus 1 is 0. Okay, now we got the output as 2, 0, and there is no borrow from here. We have not taken any borrow from here. So this carry flag will be set to 0. So the carry flag will be set to 0. We have seen if there is a borrow from to the D7 bit. If there is a borrow to the D7 bit, then the carry flag will be set to 0. As we have not taken any borrow, then this carry flag will be set to 0. We'll see one more example where carry will be taken. So we'll consider this. This is 22. This one is A2. Now we'll do the subtraction operation. 0 minus 0 is 0, 1 minus 1 is 0, then 0, 0, 0, 1 minus 1, 0, 0 minus 0, 0. Now 0 minus 1 is not possible. So what we'll do, we'll take a borrow to the D7 bit. When we take borrow to the D7 bit, then this becomes 1, 0. Then this becomes 1, 0. 1, 0 minus 1, it is 1. That is with a borrow of 1. With a borrow of 1. When there's a borrow being taken to the D7 bit, then the carry flag will be set to 1. When the borrow is taken to the D7 bit, then the carry flag will be set to 1. This is about the carry flag of program status word. Next, we'll move on towards auxiliary carry flag. Auxiliary carry flag. Okay, the name says that it is auxiliary carry. That means auxiliary carry flag is set to 1 if there is a carry out from D3 bit to D4 bit. The auxiliary carry flag will be set to 1 if there is a carry out from D3 bit to D4 bit, or it will be set to 0 if there is no carry from D3 to D4 bit. That means we know that it is an 8-bit data which we have been operating. In the 8-bit data, say 7th bit, we have bit number 7, 6, 5, 4, then 3, 2, 1, 0. This is an 8-bit data. In the 8-bit data, we call this as 1 byte. So this 4-bit together, we call it as a nibble. This 4 bits, we call it as a nibble. When there is an carry being generated from the lower nibble to the upper nibble, then we say it as auxiliary carry will be set to 1. then the auxiliary carry will be set to 1. We'll see with an example, so it will be easier to understand. We'll consider two numbers. The first number is 68, then the second number is 29. Now, when we add this, 0 plus 1 is 1, 0 plus 0 0, then this is 0, 1 plus 1 0 with a carry of 1, then 1 plus 0 plus 0 is 1, then 0 plus 1 1, 1 0. Now we can observe over here the carry is being generated from the D3 bit to D4 bit. The carry is generated from the D3 bit to D4 bit, from this to this. Then auxiliary carry flag will be set to 1. Then the auxiliary carry flag will be set to 1. That means whenever we can observe in this place, from D3 bit to D4 bit the carry is being generated, then the auxiliary carry flag will be set to 1. If we'll go with one more example, when we add this, we are going to get 1 plus 1 0 1, then 1 0 1 1 0 1, and we can see over here from D3 to D4, that is from the bit D3 to D4, we do not have any carry generated, so the auxiliary carry will be set to 0. In this example, we can see this is one nibble, this is one nibble. From lower nibble to upper nibble, there is no carry being generated, so we can say auxiliary carry is equal to 0. But here we can see that from lower nibble to upper nibble the carry is being generated, or else we can see from D3 to D4 the carry is being generated, so auxiliary carry is equal to 1. Auxiliary carry is equal to 1. This is with the auxiliary carry flag. Next we move on towards user flag, that is F0. This user flag is also known as general purpose flag. Okay. It is with the bit number 5, that is PSW.5. This bit is not affected by any arithmetic or logical operation. This is for the user purpose. This is for user purpose. If we want to use it for any of our operations, then we can use this PSW.5 bit, which will not get affected by any arithmetic or logical operations. This bit will not get affected by any arithmetic or logical operation. Next, we move on towards the register select. Register select. This register select consists of two bits in the PSW register, which is of bit number 4 and bit number 3. So we can say it as PSW.4 for RS1 and PSW.3 for RS0. That is PSW.4 for RS1 and PSW.3 for RS0. In the previous video, we have gone through the explanation of RAM structure. That is, the RAM from 00 to 7F is divided into three different sections. In the three different sections, the first section from 00 to 1F, which is being kept for register, banks. Okay. If you have not gone through that video, I have linked it in the top card. You can click on that to know about the RAM structure. Okay. That is, we have from 00 to 1FH, it has been given for register banks. In this register banks, it has been divided into four structures. That register bank is divided into four structures, that is bank 0, then bank 1, then we have bank 2, then we have bank 3. It has been divided into four banks, that is bank 0, bank 1, bank 2 and bank 3, and each bank has the register from R0 to R7. It has registers from R0 to R7. To distinguish between which bank is being used, this register select bits are used. To distinguish between that, the register select bits are used. So we can go with a table where we can easily understand. We can see it over here. This RS1 and RS0 bits, if both the bits are 0, then bank 0 will be selected. Then bank 0 will be selected. If RS1 is 0 and RS0 is 1, then bank 1 is going to be selected. Same as it is, if RS1 is 1 and RS0 is 0, bank 2 will get selected. If both are 1, then bank 3 is going to be selected. Bank 3 is going to be selected. So to select between the banks of the RAM, we'll be using RS1 and RS0 bit. We'll be using RS1 and RS0 bit. Next, we'll move on with the overflow flag. This overflow flag helps in the arithmetic operation of BCD numbers. That is, whenever we are performing any arithmetic operation of the binary coded decimal numbers, this overflow flag will help. This is the bit of PSW.2. Overflow flag will occupy the bit of PSW.2. We'll see whenever it will be set and whenever it will be cleared. It will be set to 1 if there is a carryout. If there is a carryout from D6 to D7, but not from D7 to D8. This overflow will be set to 1 when there is a carryout from the bit D6 to D7, but not from D7 to D8. And if there is a carryout from D7 to D8, and it also will be set to 1 if there is a carryout from D7 to D8, but not from D6 to D7, but not from D6 to D7. Or else it will be set to 0. That means if both carries are being generated, from D6 to D7 carry is generated and D7 to D8 carry is being generated, then overflow will be set to 0. If there is no carryout from D7 to D8 and D6 to D7, then also it will be set to 0. So we can easily say it as XOR operation. That is, overflow flag will be equal to carry of 6th bit and carry of the 7th bit. Carry of the 6th bit and carry of the 7th bit, performing XOR operation. Performing XOR operation. That means C6, C7. If both are 0, then overflow will be 0. If C6 is 0, C7 is 1, overflow will be 1. If C6 is 1, C7 is 0, then it is also 1. If both are 1, then it will be 0. If both are 1, then it will be 0. So we can say overflow flag is equal to an XOR operation between carry flag of 6, that is carry of 6th bit and carry of 7th bit. That is the carry of the 6th bit and the carry of the 7th bit. We'll see with an example to understand it easily. We'll take one example. This is a 82 and this is A2. Now, when we add these two, 0 plus 0, 0, 1 plus 1, 0 with a carry of 1, and 1, then 0, 0, 0 plus 1, 1, then 0, 1 plus 1, 0 with a carry of 1. The carry of 1. Now we can see from this 6th bit, that is the D6, okay, the carry generated is 0. We have carry generated is 0. From the 7th bit, the carry generated is 1. From the 7th bit, the carry generated is 1. If we perform the XOR operation of these two, if we perform the XOR operation of these two bits, we are going to say that overflow is equal to 1. We say it as overflow is equal to 1. We'll see one more example. Now in this, so 0 plus 0, 0, 1 plus 1, 0 with a carry of 1. Then we are going to get here 1, then 0, 1, 0, 1 plus 1, which is of 0 with a carry 1. 0 with a carry 1. Then 1 plus 0 plus 1, 0 with a carry 1. 0 with a carry 1. So we can say both from D6 and D7, the carry is generated. from the bit D6 the carry is generated here, and from the D7 bit the carry is being generated. So if both C6 and C7 carry is equal to 1, then the overflow flag will be set to 0. Then the overflow flag will be set to 0. This is with overflow flag bit. Next, the PSW.1 bit. This PSW.1 bit is reserved for the future use, or else it can be used as an user flag. It can be used as an user flag, and also it has been reserved for the future use. So we'll directly move on with the parity flag. Parity flag. This parity flag is the 0th bit of the PSW register. This parity flag helps in identifying number of ones present in accumulator. Number of ones present in the accumulator. This parity flag will be set to 1 if number of ones in the accumulator is odd. If number of ones in the accumulator is odd, P will be set to 1. It will be set to 0 if number of ones in the accumulator is even. It will be set to 0 if number of ones in the accumulator is even. Assume accumulator is equal to a value with 82H. Okay, that means 82 means 1 0 0 0 0 0 1 0, that is 82. We can, if we count this number of ones present here, it has 1 here and 1 here, that is 2 ones are been there. So 2 is an even number. The parity flag will be set to 0. The parity flag will be set to 0. If A is equal to 92H, which is of 1001 0010. Now if we count number of ones in this, we have 1 2 3 ones. That means it is an odd number. Then the parity flag will be set to 1. Then the parity flag will be set to 1. So we can say that parity flag is used to identify number of ones present in the accumulator. It is used to identify the number of ones present in the accumulator. If the number of ones is odd, then it is going to be 1. If number of ones is even, then it is going to be 0. Next, the program status word. It is present in the special function register. It's in the special function register. The address of that is D0H. The address of the program status word in the special function register is D0H. So we can say that the program status word can be accessed by its address also, that is byte address also, or it can be accessed by its name, that is PSW. Name, that is PSW. And it is also an bit addressable register. Program status word is also a bit addressable register. The bit address of this program status word starts from D0H and it ends at D7. It ends at D7. If we want to access the parity flag, we can directly access the D0 bit, or if we want to access overflow flag, we can access the D2 bit directly. The above row gives the bit address and the below row gives the symbol of that. That is, for parity it is D0, for overflow it is D2, then carry D7, auxiliary carry D6, like that. So program status word is also an bit addressable register. Program status word is also an bit addressable register. This is with respect to the program status word. If you have liked the video and if you found it has been helpful, okay, please click on the subscribe button and don't forget to click on the notification icon so to get notified for the further videos. The theory content of the concept have been uploaded in our website www.rlc.eee.com. You can subscribe to a social media platform to get updated for the further videos and the concepts. If you really like the video, click on the like button and share it with your friends and well-wishers. Thanks for watching. We'll see you in the next series.